Wait, do you guys understand the statement of this question? So you basically have a bunch of people or jugs like in a circle, right? And they all have a certain amount of sugar and like non-sugar. So like water and sugar or something, yeah? But it's always possible in one direction to pour it so that you pour it so that the final thing is 10% sugar. That makes sense? Okay. But then the question is,
What?
if that's possible to do, like if it's always possible to pour once so it's 10%, is it possible to keep pouring like in some order so that everything ends up as 10%? Okay. And for the sake of this question, having nothing in the jug is counted as 10% sweetness. Okay. So Liam came up with some good ideas, which not necessarily very easy to write up. Okay. But then also this other student we saw, like Raiden, came up with a really good idea. So basically, let's show you the sort of the, I don't know how much you thought about this, but there's some obvious things. So like, if you have like 10% sweetness in one jug, right? Yeah. And this jug is greater than 10% sweetness, yeah? So no matter how much you pour into it, it's going to stay greater than 10% sweetness. Does that make sense? Like if something's greater and something's equal, and you keep pouring it, it's going to stay greater. Does that make sense? Okay. Similarly, if one of them's greater and the other one's greater and you keep pouring, it's also going to keep being greater.
So that means that you can have two types of circles. One is that every one of them is 10%, in which case you don't have to pour anything.
You're done, yeah.
Other one is there's one that's greater than 10, followed by one that's not as great as 10, followed by one that's greater than 10, and so on.
Yeah, exactly. It has to alternate, right?
Yes.
So like less than 10, greater than 10, less than 10, greater than 10. And so it has to be even for it not to have, you can't have two that's like less in a row, yeah?
Definitely didn't get that from you, so.
No, Liam got this part, yeah?
Yeah.
So he got the part with equal or greater than, and alternating this even, yeah? But then he did some crazy claims where basically he's claiming that when you pour something, you have to pour all of it.
I did that.
Huh?
What?
And then if you have to pour all of it,
That's empty.
yeah, then you get some empties. And I mean, it's kind of like a clever argument with the fractions to say they have to pour all of it and stuff like that, right? But there's actually a much more basic way to summarize all of that in terms of this question. So notice the thing that's harder is not necessarily worse because it actually proves more, okay? So that's the thing you got to notice. When it proves more, so it proves you have to empty like basically all the pores. That's different than just knowing that there is a way to do it, okay? But actually the way to do it also tells you exactly like how you do it. So observe this thing, okay? It's pretty nice. So this is the essence of Raiden's solution, okay? So you start here, okay? And you pour into it until this is equal to 10%, yeah? So we know that's possible from the assumption of the question, yeah? So it's possible to get this to be 10%, yeah? Okay. Now, we want to get the next one to be 10% as well, okay? And we know it was possible originally, okay, to get 10%, but now we might not know it's possible because now it has less than it originally has, right? But if it has less than it originally has, then you would need to pour less to make it 10%. So it's still possible to make it 10%. Does that make sense? But it wouldn't work if you needed to pour more because you might overflow and yeah. You might need to pour more than there exists in the other jar, right? Okay. And so you just keep doing this all the way around, right? That makes sense? until you get to the last one. So basically what you have is all of these things are 10%, right? Okay. And then you have one last jog left. Yeah? And, well, there's two possible cases. The jog is either empty, right? In which case you're done, okay? So you've achieved the goal. So we don't have to, we can assume it's not empty, yeah? But if it's not empty, it's going to have less than 10% because it originally had less than 10%, right? So what that means is the overall concentration, if we poured all the jugs of liquid into a bathtub, okay? If we poured it all into the same bathtub, then the overall concentration is less than 10%, right? That makes sense? Okay. But we could have just as well started, instead of starting here, we could have just started here, right?
Any other job.
Yeah? If we just started here and did the same thing, then the last jug that we'd be talking about would be this jug, right? Yeah? And then it could be empty, in which case we're done again, right? Or it could be non-empty, and then we'd have something greater than 10%, right? And if it was greater than 10%, then the overall concentration, if you poured it all together, it would be greater than 10%, right? But it can't be both greater than 10% and less than 10%. So therefore, it has to be empty, okay? Or one of them has to be empty, yeah? And if one of them's empty, you're done, yeah. That's pretty nice, right? Any questions?
Yeah, that's pretty nice.
I mean, I was trying to already roughly summarize it. It's basically, it's kind of like this, but you're saying you have to pour all of it in every time you pour.